Oh yes, you seem to have caught me as I am pondering upon an antique edition of the Webster's New World Dictionary. As a matter of fact, that is the new data type that we were going to be learning about in Python today, the dictionary. The dictionary is the last type of Python object that we're going to be learning about in this series. And dictionaries are frankly really cool. They're one of Python's more unique features, and they're so useful for all kinds of programming things. Basically, what a dictionary is it is a matching of a key to a value. So on the left side you'll have a key, which could be some object as long as it's immutable. So for example, an integer or a string. And then you map on the other side some kind of value, which could be any object that you want, even mutable ones, so an array or a set. And what a dictionary allows you to do is it allows you to keep all of these data stored in one place, but easily retrieve them from the key value. So you can retrieve any value in your dictionary by using the key, which is pretty cool. The other advantage that dictionary has is that it is hashable, which means you can look up any of the contents in the dictionary fairly quickly, especially if you're using the key to retrieve a value. Not so much if you want to retrieve a key from the value. It doesn't quite work in reverse, but we'll see how we can work around that. Anyway, let's get started with programming some dictionaries in Python. Let's take a look at what dictionaries have in store for us. So to initialize a dictionary, you're first going to want to start by making some kind of name to hold it in, some kind of variable, and an equal sign. And to actually initialize a dictionary, you use curly Q brackets. Now this is very similar to like what we did with a set. And with a set, you would just go right ahead and you would list the elements that you want to put in order. The way to differentiate a dictionary from a set is that your dictionary, when you initialize it by typing in your values, should have key value pairs. And that's how Python recognizes the difference. So this is actually perfectly okay as an empty dictionary. But let's say we want to populate this. Let's say I want to make an actual literal dictionary with some words. So we're going to make some key value pairs. And I'm just going to use strings. But the beauty of dictionaries is that, for the most part, with some restrictions, you can use any kinds of objects that you would like. And I'll show you what the restrictions are in just a second. So let's say we wanted to take the word apple, right? And this will be my key. And to pair a key to a value, the key goes on the left, you put a colon, and then on the right you put its value, which is the value that it corresponds to. So let's say I want apple to match to apfel, just like that. And then to make another entry in the dictionary, after you have your key value pair, you're going to put a comma, and then you can do another one. So let's say I want cat, and then I'm going to match that to Katze, just like that. See, there's another key, and its value pair works just like that. And I'm going to show you kind of what this looks like if we want to look up data from a dictionary. So let's say I want to print the word that corresponds to apple. You can only really look up by keys in dictionary unless you have a reverse-facing dictionary. I'll go over that in a second. So we're going to put Webster here, which is the name of my dictionary, and then in square brackets, put the name of the key that we want to look up. So we want to look up the key apple, and then when we hit print, it prints apfel, which is the value that corresponds to apple. And so that's all great. And then if we want cat, it'll do something similar. And instead of printing the actual key, it prints the value associated with it, which is Katze. Now, what if we wanted to retrieve the word cat from Katze somehow? You really can't do that. So let's see, if I try to use this lookup here, and I type in the value, it's going to give me an error. It gives me a key error because there's no such key named Katze in this dictionary. And that's why it yells at me, because a dictionary can only look up a value from its key. So you give it a key, and it can give you the value back. Well, technically it is possible to get a key back from the value, but it's very long and expensive and lengthy process, and it becomes a mess when your dictionaries are large. So the way to get around this is if you wanted to make a reverse-facing dictionary, which is where you basically manually create the same dictionary again, and instead of your keys to values, reverse them. So let's say we'll stick with this example. So now we have our value, which maps to our key. So then if we want to look it up again, now we know to look in the reverse-facing dictionary, and then we can get what we were looking for very quickly and efficiently. So this is an example where we just have a one-to-one matching of strings as a key on one side to strings as a value on another side. However, as I mentioned before, you can use different data types, and it doesn't necessarily always need to be a one-to-one matching. So I'll create another dictionary. We'll call this fools, and we'll use the curly Q brackets, and instead I can use an integer as a key. So instead I can say 4097, and I can make a colon, and in the value I can actually make a set in place. So let's just make a set of random names. So we have Kyle, Isaac, Justin, Dizel. Again, these are just absolutely random names that I just came up with. They have no connection to anything whatsoever. But now that we have all of these names in here, if we wanted to look up, say for example, we wanted to look up what is stored in the key 4097 of the Fools dictionary, right? So we'll go to print Fools and then 4097, and it will print our set of names. Just about the only restriction on data types with dictionaries is that the keys must be immutable, which means they must be some kind of unchangeable data type. So for example, I have this set here of cars, and that is a mutable data type. So if I try to make the key of this cars, we'll just delete this line for right now, and I try to run this, it's going to yell at me because unhashable type, whatever, blah blah blah. The way to make this go away is just simply choose some kind of immutable data type. So instead I can cast this as a frozen set, which we learned about last week, and then when I try to use cars, it'll work because now my key is immutable. See, the program went through and it didn't throw any errors in my face. As a general rule, avoid using sets and lists as the key of your dictionaries. Let's take a look at what kind of utilities or features dictionaries offer. So let's say I want to merge these two dictionaries that I have here, so all of my fools and all of my clowns are in one place in one dictionary. We're going to use the update keyword for that. So I'll use fools.update, and inside the parentheses put the name of the other dictionary that you want to merge. In this case, this is clowns. And then so when we print the Fools dictionary, what we've done is we've mutated the original Fools dictionary to now include both fools and clowns. So as we can see, we have the key 4097, which corresponds to a set of these four names, and then we have the key 119, which includes the set of these three names. And if we wanted to, what we can also do now is we can delete keys from a dictionary. So let's see, I want to get rid of the key 119. So you would use the delete keyword like this, and then use the dictionary fools. Remember now fools includes both of these, and then use the square brackets to choose a key. So in this case, if we want to delete 119 and then we print fools again, we can see that we've deleted 119 out of the dictionary and we just have what we originally started with. There's a few other cool things that we can do with dictionaries to re-represent them in different ways. So we're used to looking at the dictionary as a pair of keys and values. However, there are ways of looking at just one or another, and for this we can use either the keys method or the values method. So instead of printing fools, we can print fools.keys like this, and make sure you put a pair of empty parentheses around keys just like that, and then when we hit print, it returns a list of all of the keys that are in our Fools dictionary. So that is 4097 and 119. Similarly, we can do something very, very similar with values, where we use fools.values. So this is the values method within the dictionary. And when we print that, it gives us as a list all of the values, which is the two different sets of names that we have. And these are now lists that we can iterate across and do all kinds of things with. This becomes very useful in the future. One last one that's kind of similar is items, which gives us a new representation of both keys and values together. So I'll show you what this looks like. It gives us a nested list where on the outside we have the list, and then each of the elements of the list is a tuple which pairs the key on the left side to the value on the right side. So this might be kind of hard to follow or hard to see, but this is a list with two elements, and each element is a tuple with two elements. And each of the tuples elements on the left is the key, and on the right are the values. And then finally, the last method that I want to show you is the very self-explanatory clear method. So if you type in the name of your dictionary.clear, and remember to put two parentheses at the end because this is a method, when you print this, it just clears out our dictionary and then just gives us something empty. So fools has been entirely cleared and doesn't contain any objects or anything at all. It's just the two curly Q brackets. One last really awesome feature of dictionaries is that, much like sets, dictionaries are hashable, which allows you to have very quick constant time lookup using the in keyword. We saw this before when we kind of sort of index into the dictionary to retrieve a value. That's part of the hashing too, but we can also use a dictionary like a set to directly look to see if a key is present in the dictionary. So for example, I'm looking at my Fool's dictionary to see if the key 119 is present, and indeed it is. So we print our little phrase down here, expression of joy and excitement. This doesn't work the other way. So for example, you can't use any of the values. So like this set of names is one of the values, and it won't work the other way. So it'll tell you, hey, like this doesn't work, and it'll throw an error. So just remember that dictionaries only work one way, from retrieving values from keys or for looking to see if a key is in the dictionary. If you want to do it the other way, you'll need another reverse-facing dictionary. So to conclude my video, I want to show you a little pet example of what you can use dictionaries for. So let's say, like any fiscally responsible builder dude, I like to keep track of all of any outstanding loans that I give to any of my friends. So what I've done is I've initialized a dictionary called debts, where each of the keys are the names of some of my friends, and the value is how much money they owe me at any given time. And I've initialized them all to 0 because at the beginning of year, none of my friends owe me anything. But now let's say Isaac needs to borrow some money for pizza. So index, or not index, but go into the debts dictionary and choose the key Isaac, and this now symbolically becomes the value that is associated with the key Isaac. So this whole expression has become the number 0, which is interesting, and it's kind of strange to wrap your head around, but just accept it at face value for a little bit, and once you get more practice with it, it'll become more intuitive to you. So let's say he borrows $5 to borrow pizza from me, right? So now we can print the debts dictionary, and we'll see what's going on with that. Now we see that the value associated with Isaac has increased to 5, and the others are unchanged at 0. Now let's say instead Dizelle borrows $20 to buy a new t-shirt. So I'll change that to Dizelle and we'll say plus equals 20. And much in the same way, we have changed the value associated with Dizelle to 20 within the original dictionary, which is pretty cool, right? And you can even stack these on top of each other. So let's say, for example, Dizelle borrows $20 from me, and then he gives me $5 back. So we can subtract $5 from the outstanding debt that he owes me. And then that changes it back to 15. And you can use all kinds of math operations you want, and you can even directly reassign numbers instead of adding. So I can say that directly owes me $45, and it changes the value just like that. So this is a little pet example of something that you can use dictionaries for keeping track of different values that are associated with keywords. Thank you for watching my tutorial this week. If you haven't already, be sure to check out my book. It's called Building Smart LEGO Mindstorms EV3 Robots, and it's now available on Amazon. If you found this tutorial helpful, be sure to subscribe to my channel to get more tutorials like this every Thursday. And if you have an idea for a tutorial, leave it in the comments section below. Thank you, and I'll see you next time. Oh yes, you found me reading an antique edition of the Webster's New...